Bonjour à tous, un dimanche matin en plein confinement, nous allons corriger l'activité Quadratic Functions. Quadratic Functions. Definition. Quadratic functions can be written as f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is non-zero. Exercise 1. Which of the following are quadratic functions? Let's see. A. F of x is minus 2x squared plus 3x minus 5. So this is a quadratic function with a is equal to negative 2, b is equal to 3, and c is equal to minus 5. b, f of x is equal to 1x squared, so a is equal to 1, b is equal to minus 5, and c is 1. c, f of x is equal to 3x plus 10x squared minus 7. So that's a little tricky. The a is the coefficient of x squared, so it's 10. b is the coefficient of x, it's 3, and c is negative 7. d, f of x is equal to 2x plus 1. There's no x squared in this expression, so we can say that a is 0, and it's said in the definition that a should be non-zero. So this is not a quadratic function, this is a linear function. E, f of x is negative x cubed plus 2x minus 5. Of course, there's an x cubed here, and it's not supposed to be here because in a quadratic function there's only an x squared, x, and constant terms. So this is not quadratic. f of x is equal to x squared plus 3. So a is equal to 1x squared. b is equal to 0 because there's no x terms here. But it's allowed. We can have b is equal to 0. And c is equal to 3. So this is a quadratic function with b is equal to 0. And g, f of x is equal to 3x squared minus x, a is equal to 3, b is equal to negative 1, and c is equal to 0, and it's allowed. So this is a quadratic function. h, f of x is equal to 1/3 of x squared plus 4x over 3 plus square root of 3. A is equal to 1/3, so it's allowed, it's a fraction, but it's suitable. A. We can write 4x over 3, we can write it down as 4/3 times x, so b is equal to 4/3. And square root of 3 is c. So this is a quadratic function. I, f of x is equal to x squared over 5 minus square root of 2x. In this case, we have an x under the square root, so this is not allowed in a quadratic function. So let's draw all these functions and see what quadratic functions have in common. First one, a, f of x is minus 2x squared plus 3x minus 5. We can see that this curve is a parabola. The second one, which is also quadratic functions, x squared minus 5x plus 1. It's the red parabola here. We can see that the first one is facing downwards because the leading coefficient A is negative. And the second one, G, is facing upward because the leading coefficient 1, A is equal to 1, is positive. The third one, h of x, C, 3x plus 10x squared minus 7, the leading coefficient 10 is positive, and the parabola is facing upwards. P of x, that's D. The graph is a straight line, of course, because the function is linear. And so this is not a quadratic function, and the graph is not a parabola. E. Q of x is minus x cubed plus 2x minus 5. Of course, the graph is not a parabola, and this is not a quadratic function. F. R of x is x squared plus 3. This is a quadratic function, and the graph is a parabola facing upwards. G. S of x is equal to 3x squared minus x. And this is the blue parabola here, facing upwards, because the leading coefficient is 3, positive. I guess this one is I. G of x is 1/3 of x squared plus 4/3 of x plus square root of 3. And this is a parabola facing upwards, the orange one. And finally, f1 of x, this is J, I think. We said that this is not a quadratic function, and of course the graph is not a parabola. As you can see, it stops here at the origin of the axis. So this is not a quadratic function. So, conclusion. Theorem. The graph of a quadratic function is a parabola, always. If the leading coefficient A is positive, the parabola faces upwards. If the leading coefficient A is negative, the parabola faces downwards. The next theorem is about completing the square. By completing the square, a quadratic function can be written in standard form, which we call also vertex form. This is f of x is equal to a times x minus alpha all squared plus beta, where a and alpha and beta are real numbers. So a of x is x squared plus 4x minus 1. And we can see that x squared plus 4x is the beginning of the identity x plus 2 squared. But we're missing the plus 4. So we have to say that x squared plus 4x is x plus 2 squared minus 4. The minus 1 remains here. And so we get x plus 2 squared minus 5. B of x is 2x squared minus 4x plus 6. First we factorize by 2 to get 2 times x squared minus 2x plus 3. And we can see that x squared minus 2x is the beginning of the identity x minus 1 squared. but we're missing a 1 here, so we have to put a -1 here. The +3 is still here, and we get x minus 1 squared plus 2, all multiplied by 2. Now we multiply out 2, and we get 2 times x minus 1 squared plus 2 times 2 is 4. The last one, c of x minus x squared plus 2x plus 5, we factorize by -1, all multiplied by x squared minus 2x minus 5. We can see that x squared minus 2x is the beginning of the identity x minus 1 squared, but we're missing the +1 here, so we have to put a -1 here. So we get minus x minus 1 squared minus 6, and we multiply out -1 here to get minus x minus 1 squared plus 6. Now we have to give the coordinates of the vertex. For a of x, we found that a of x is x plus 2 squared minus 5, which we can write 1 times x minus -2 all squared plus -5. And so alpha is -2 and beta is -5. We can check this on the graph. This is the parabola corresponding to f of x, x squared plus 4x minus 1. And we can see the vertex here, -2, x is -2, y is -5. For b of x, we found that this is 2 times x minus 1 all squared plus 4. So alpha is 1 and not -1. It's x minus alpha. Beta is 4. So we can check this on the graph. This is the parabola, and the vertex is x is equal to 1, y is equal to 4. The last one, c of x, we found that this is minus x minus 1 all squared plus 6. So alpha is equal to 1 and beta is equal to 6. On the graph we can see that alpha is equal to 1 and beta is equal to 6. Now we have a definition and theorem about the discriminant of the quadratic form. The discriminant is delta equals b squared minus 4ac. And we have formulas for alpha and beta. Alpha is equal to negative b over 2a, and beta is equal to negative delta over 4a. So exercise 4, find the vertex form and give the coordinates of the vertex. For a of x, alpha is equal to minus b minus 4 over 2 times 1. A is equal to 1. So we get alpha is equal to negative 2. Delta is b squared 4 squared minus 4 times a, which is 1, times c, which is negative 1. And we get delta is equal to 16 plus 4 is equal to 20. And beta is equal to minus delta minus 20 over 4 times a, which is 1. So beta is equal to minus 5, as we found here. for p of x, alpha is equal to minus b minus 4 over 2 times a 2 times 2. So this is 1. Delta is equal to minus 4 minus b squared, minus 4 times a, which is 2, times c, which is 6. So it's 16 minus 48, negative 32. And beta is equal to minus b, so minus 32 over 4 times a. A is 2. So beta is equal to 4. That's what we found here. And finally, for c, alpha is equal to minus b over 2a, so minus 2 over 2 times minus 1. This is 1. Delta is equal to b squared minus 4 times a minus 1 times c times 5. So this is 4 plus 20, 24, and beta is minus 24 over 4 times a, which is 6. And that's what we found here. The next theorem is about the solutions of the equation ax squared plus bx plus c is equal to 0. And we have two situations where we have solutions depending on delta. So if delta is positive, then the equation has two solutions. x1 is equal to minus b minus square root of delta over 2a. x2 is equal to minus b plus square root of delta over 2a. If delta is equal to 0, then this equation has only one solution, x0 is equal to minus b over 2a. And if delta is negative, this equation has no real solution. So, exercise 5, solve the following quadratic equations. First one, a minus x squared plus 2x minus 5 is equal to 0. Delta is equal to minus 16, which proves that this equation has no real solution. B, 8x squared minus 2x minus 1 is equal to 0. Delta is equal to 36, so we have two solutions because delta is positive. So x1 is minus b minus square root of delta over 2a, and this is minus 1 over 4. The second solution is x2, 1/2, c, x squared plus 6x is equal to 0, delta is equal to b squared minus 4 times a times c. C is equal to 0, so we get only 36. We have two solutions because 36 is positive. x1 is minus b minus 6 minus square root of delta over 2a. So this is minus 6. And x2 is equal to 0 because minus 6 plus 6 is equal to 0. So the two solutions are negative 6 and 0. We can also solve this equation by hand, by factorizing by x. And then we can see that this is equal to 0 if and only if x is equal to 0 or x is equal to negative 6, which amounts to the same thing as what we did before. It's just a little bit short. D x squared plus 2x plus 1 is equal to 0. Delta is equal to 0. So we have a unique solution. x0 is equal to -1. We can find the same result by using the identity here. X plus 1 squared is equal to 0. If and only if x is equal to -1. Same solution. E, 4x squared minus 1 is equal to 0. Delta is equal to 16. The two solutions are x1 is equal to -1/2 and x2 is equal to 1/2. We can solve this equation by factorizing using the identity 4x squared minus 1 is equal to 2x minus 1 all multiplied by 2x plus 1. And we found the same result, 1/2 and -1/2. We can check our result using the graphs. For the first function, we can see that we have no solution, no intersection with the x-axis. For the second one, we have two solutions, -1/4 and 1/2. For the third one, we have two solutions, 0 and -6. For the fourth, only one solution, -1. And for the last one, we have two solutions, -1/2 and +1/2. The last theorem is about factorization. If delta is positive, then we can factorize the quadratic function by a times x minus x1 times x minus x2, where x1 and x2 are the roots that we found before. If delta is positive, then we can factorize, there's a mistake here. If delta is equal to 0, then we can factorize by a times x minus x0 all squared, where x0 is the unique root of the function. And if delta is negative, then f of x cannot be factorized. Exercise 6, factorize the quadratic functions in exercise 5. So the first one cannot be factorized because we found that there are no roots, no solutions. In B, we found the two solutions -1/4 and 1/2. So we can factorize by 8, this is a, x minus x1 times x minus x2. We can simplify this by 8 times x plus 1/4 times x minus 1/2. C, x squared plus 6x. We can factorize this x minus 0 times x minus 6, x plus 6. A is equal to 1. In D, we can factorize because we have one solution. So this is a is equal to 1 times x minus x0 squared. x0 is equal to -1, so x minus -1 is x plus 1. And finally, 4x squared minus 1 is equal to 0. So this is the function 4x squared minus 1. The roots are minus 1/2 and plus 1/2, and we can factorize as 4 times x minus 1/2, so x plus 1/2 times x minus 1/2. Notice that this is the same as the other factorization we found before. We just have to multiply at a 2 in the first bracket and another 2 in the second bracket. And then you get this. And that's all. Bon bah voilà, j'ai pas beaucoup bougé depuis tout à l'heure. Je voulais essayer de faire une vidéo en anglais. L'accent allemand est absolument terrifiant. J'espère que ça vous a aidé quand même. Au revoir à tous.